So we here at the ARM TechCon 2011. So what do you think so far?
This is by far the best show that they've had on. I think the trend, as I've seen, I've come to these for a while, where what ARM was talking about was considered sort of a niche in electronics, where today in this show, I think what we're seeing is that this has become the mainstream. And industries like the PC, which used to be the mainstream, now is becoming more of a niche. So I think this is ARM's coming of age show. I really do.
Last year they announced, I think, 6 billion processors shipped.
Yep.
Isn't that crazy?
Oh yeah, and that's what the volume started to catch a lot of people's attention. But what's catching everybody's attention now is that everybody's running into the power problem, and all of a sudden, power is the main problem we've got in electronics. And then, well, as the talk this morning said, in the whole world. So power is the issue. We're seeing the whole semiconductor roadmap being affected by the power problem. So people have had these grand schemes of doing 5 gigahertz, 10 gigahertz processors, and now what they're starting to understand is that's not going to happen. We have run out of the gigahertz thing is becoming a joke now. I mean, when you talk to the mobile guys, and I talked to quite a few mobile guys today and yesterday, and actually for the last 3 days. They're telling me that the sweet spot for the frequency is somewhere around 400 megahertz. So, I'm glad you're introducing processors that can do 2-point-some-odd gigahertz, but the mobile designers just laugh at these guys, the processor guys, when they start talking frequency, because they don't understand the power constraints that we're under.
Is that why the ARM 7, what's called Cortex A7 is a good thing?
The 7 is brilliant. I mean, that's not a good thing. That's a brilliant move. I mean, that is really shows the work that's been going on at ARM. I consider, when I talk about processor architectures, I consider the 2 top people today to be NVIDIA and ARM. Those guys understand what's going on. Those guys have a very clear a view of the future, where when you talk to other processor vendors, you're still talking about a Van Neumann architecture, which means the only way you improve performance is to speed up things. There's no other option. Well, what we're seeing now is we're seeing this shift over to parallel architectures, to a lot of non-Van Neumann architectures that are taking advantage of parallelism rather than push the frequency, because the frequency kills you with power. Now, today, power isn't the problem. Power is the specification. So the engineer walks into a project, and the first thing he handed is a power budget. Okay, now, see how many features you can put into this and how much performance you can put into this, and don't exceed that budget.
So we like this is where Intel is in trouble, or
this is where Intel's in trouble. They're still thinking Van Neumann processor, and they haven't they haven't got some people within Intel have. I mean, they're getting there, but there's still most of the upper management has lived in this Van Neumann world for their whole career. And now all of a sudden people are saying, hey, this doesn't work anymore. And they're being slow to react to the change. And I'm saying this show shows that the change has happened. You should have reacted to it before this point.
So what do you think about Mike Miller's keynote?
Oh, I love Mike. I mean, Mike's really interesting. Except for the scale part, I love Mike.
Except what scale part?
Having the guilt scale. In fact, I want to give him a screw guilt sticker so he can handle that problem. But oh yeah, that was a brilliant keynote. I love Mike. I try not to miss anything that he says.
Maybe in the U.S. people have a tendency not to feel guilty about the weight.
Yeah, well, that's something to do, but yeah,
I don't know.
Yeah, just creates stress.
And what do you think about the UN getting involved and trying to get, let's say, more people to use ARM-powered desktops, to use less power than all the servers also use so much power on this planet.
It's a worldwide problem. So, power is the issue that the whole world is facing now. And that's why we have to go to other forms of computation. We can't use the old Van Neumann computers anymore.
We have to use 100% of all the clock cycles for something, and the ones we don't need, we shouldn't have them running.
Oh yeah, we have to shut down everything we can shut down. That's obvious. That's the dark silicon. In fact, one of the things that I'm going to write about is that people make dark silicon sound like a bad thing. Well, no, it's a good thing because it's saving energy. I mean, anything that saves power, saves energy, is good. And if you have to shut off most of your SoC to get within your power budget, well, really, in an apps-driven world, you're not going to use everything at the same time. I mean, a cell phone, what are you going to do? You can't talk on the phone and do 20 other things, and what people are crying for is more and more apps. Well, more and more apps means more and more silicon, more and more processing areas. Well, a lot of those are just going to be dark for extended periods of time. Where computer architectures are aiming for is what's called instant on, normally off computing. And that's where, and my son is a good example of that. When Lori Kate got the iPad, he uses our home computer as his toy. I mean, he's the one that uses it most of the time. We have our work computers. So he plays his games on the home computer. Well, she got the iPad, and he loved the iPad. He wanted to play with the iPad all the time. And I asked him, well, why don't you use your computer, or our computer? And he says, it takes too long to turn on. So here's a 6-year-old kid giving you a marketing input. It's got to be on immediately, instant gratification. And as far as the power is concerned, you need to turn everything off as soon as you can, as long as you can. So this is an instant on, normally off computing that we're aiming toward.
Do you think just marketing and sales processes will do this, or do you think politics will get involved and will kind of regulate power usage?
Politicians have a tendency to try to jump in and take credit for things. So, will politics get into it? Yeah, it probably will, but really the drive is economics. Capitalism works. I mean, the power problem is costing us tons of money. Oil prices are going to go skyrocketing because we're running out of oil. What do? Go electric. Because in the long run, it's going to be cheaper. So
the ARM V8, the 64-bit processor, is going to use more power.
It'll use more power. It just completes the arsenal of products that ARM is attacking. I mean, they're going to be in servers. They're starting to be in servers. There's no application that's safe because the ARM architectures, the ARM philosophy, the ARM direction is really around heterogeneous computing. One of the problems with the cloud is that if you look at the assumptions around the cloud, that's a homogeneous computing environment. Well, we're not going to be doing that much homogeneous computing. It's going heterogeneous. And the reason it goes heterogeneous is that's the best way to save power. They want you can give them performance and the power savings at the same time. In a homogeneous situation, you're dealing with suboptimal computing. I mean, it might work fine for one application, but for general purpose computing, it's just not efficient, and it eats up power.
All right. So who do you think I should go and try to interview here at the conference?
If you can get a hold of Fergie, grab a hold of Fergie.
Ian Ferguson?
Yeah, Ian Ferguson. Jem is always a good source of information. There's a TI, David Carlson from
Right.
TI. I mean, TI really understands this stuff. So he'd be a great guy to talk to.
Cool, thanks.